So we have a quite broad and balanced portfolio of missions in NASA astrophysics. There are about 60 projects listed on this chart by project status and by wavelength. About 25 missions are orbital class, and about 35 of these projects are suborbital class. And this is the base on which the Decadal Survey made recommendations. What should we be doing going forward, given that this is where we're starting? The agenda for today's town hall will include an update on the James Webb Space Telescope commissioning status. It'll include a report on the budget that was requested for NASA astrophysics for next year, fiscal year 23. And then the bulk of the time will be spent letting you know what NASA's preliminary responses and actions are following the receipt of the 2020 Decadal Survey back in November. We'll leave time for questions at the end. But first, a word from our sponsor. This town hall is sponsored by Black Hole Week. Black Hole Week is going on now, May 2nd through 6th. It's a celebration of black holes through social media. You can find it all over the internet. Just search for hashtag Black Hole Week or search for NASA Black Hole Week. And you can find our videos and our features and a lot of good science, but also a lot of good communication for the general public who is very interested in NASA astrophysics, including all the black holes we're finding. All right, the first topic is the status of the James Webb Space Telescope commissioning. So, Eric Smith, take it away, and I'll advance your charts. Just tell me when to go.
Okay, thank you very much, Paul. So let's just dive right in here and we'll talk about the commissioning timeline that Webb is on. Following the launch on Christmas Day of 2021, we first proceeded those first 30 days. There were that orange segment to the left of the bar where the spacecraft was tested out. These are where all the deployments had to happen, and they all happened successfully. We then transitioned into the telescope commissioning, which is the longest by time and actually most steps in it. And this is where we got our 18 segments in the primary and secondary mirror to work perfectly as one giant telescope. And we'll show a picture of that coming up next. But right now we find ourselves in the instrument commissioning phase. And there are literally more than 1,000 activities that have to happen during this phase that bring the instruments into positions where they are calibratable. They will have been commissioned and they will be calibrated at some level to start science, but calibration occurs all through the cycle one and improves with time. So this is where we are. We'll be going through what are called hot and cold attitudes. That's the next big activity where we move the telescope into relative hot attitudes and cold attitudes to see that effect on the instruments and the mirror. But let's actually jump right to the next slide. And this is an image that came out recently, and it shows all the instruments with they're open to the sky. We're looking at the Magellanic Cloud here, and you can see the wavelengths along the bottom. And the important thing to note in this is that we are meeting the level 1 requirements of being diffraction limited at 2 microns in the near infrared and at 5.6 microns in the mid infrared, and the mirror instrument there in the upper right hand part of the slide. This is how the focal plane is laid out, minus the little call outs that are in there. So this is, if you were to open the instrument all up at one time and take a picture, this is sort of what it looks like. Of course, we wouldn't do that normally. Normally, the fine guidance sensor is guiding and not taking pictures like it did here. What we're doing now, we'll be starting analysis of the backgrounds that we see. Some very preliminary analysis indicates that the backgrounds meet the requirements. And of course, that's a challenge because we do have this open architecture. So it's good to know that we're seeing what we expected to see as far as the sky backgrounds, but there's a lot more analysis and observations that will be taken during the instrument commissioning phase to confirm that. But this was certainly a big moment in the life history of Webb when we can confirm that we have the telescope that is going to meet the science requirements that we've all been waiting for these many years. Next slide, please, Paul. So in that timeline that I showed before, we know that it's the CAST, it's the sequence of activities that occur during commissioning. We've completed those first two colored bars, the orange and the green there, for spacecraft and telescope. And now we're in that last set. But you can see, even though it's the final one and the smallest as far as number of steps, it's the one that concerns our bread and butter, the science instruments. And we're going to return all those wonderful data, and that's where we are right now. And then just as an example, I have the next slide showing the kind of activities that go on. And this is just for NIRCam. And in fact, we're right up against that little yellow bar there where it says the hot attitude. We're getting ready to go into that positioning. And so we've already started to do some of the commissioning of the NIRCam. And you can see that it is actually the first instrument to be commissioned, but it joins the whole observatory out there at the day 180, which is near the end of June. And so that's where we are in commissioning. It's going well so far. It's gone amazingly well up to this point, and we hope that that continues through the science instrument commissioning. Let's go to the next slide and talk about what's going to happen right after that commissioning. Well, we're going to get into cycle one, and cycle one comprises these three major sections: the GO, the General Observer pool of proposals, the guaranteed time pool, which are from members of the Science Working Group who've been helping us with the observatory these many years, and then the all-important Director's Discretionary Early Release Science. And these are the 13 programs that will be executed sort of within the first 5 months of operations so that their data can be made public immediately. And the high-level products and analysis tools those teams have generated to help people get ready for proposing for cycle two. This is a way to get JWST data into as many hands of community members as possible. And so there you can see formally when cycle one begins there right around the end of June. That's assuming that all the commissioning steps complete on their planned schedule. We go to the next chart. This is now kind of stepping out a little bit and looking, once we start that, when would cycle two happen? So about November is when the call would go out, and then there's a date in January when the proposals would actually be for cycle two. But this is where we want to get those early release science data into the hands of folks before they have to submit their cycle two proposals. And we're on, hopefully those will execute on time, and we'll get those into your hands. Next slide, please. This is just to highlight what we're going to be doing from a public outreach, public education standpoint, right around the time of transitioning from commissioning to operations. And those are at the release of the early release observations. Some 622 sites around the country, and I think there will be some internationally as well, will have events to highlight these first data that come public. And if some of these places are near you, and considering how many locations there are, you're probably close to some of you, and you'd be interested in getting involved in some of these, sort of serving as a subject matter expert, perhaps, feel free to get in touch with me, and I can put you in touch with the folks who are running these community events. It's being led by Anita Day at NASA headquarters. She ran a program like this for the launch too, at about 450 locations, and it's even more. They're going to be participating in the release of the first data from Webb. And I think that might be my last chart. Could you advance one more, Paul? Oh, this is just if you want to stay current with how things are happening on Webb. There's, of course, the Webb blog that gets posted once a week, at least once a week, where we detail what's happening during commissioning, hear a little bit about some of the science that's going to be coming up as well. There's, of course, all the social media that Webb participates in, and we still encourage people to go visit the Where is Webb website to see what's happening on a day-to-day basis. And you can also read the instrument temperatures off there if you're really inclined to. So I think that is my last slide.
All right.
Okay, thank you very much.
Thank you very much, Eric. I appreciate that. We'll now move into the next piece, which is an update on the budget. I should have done a little housekeeping at the beginning. These charts are posted already on the NASA website at science.nasa.gov/astrophysics/documents. Also, at that same page will be a link to uh, the advertisement for this town hall, which is where the portal is for submitting questions. We will answer all the questions that were submitted as of this morning. And if we have time, we'll look at additional questions. All right, well, uh, uh, this budget was submitted following some great accomplishments by NASA Astrophysics. Eric has just updated you on the successful launch and deployment of the James Webb Space Telescope. We're making great progress on the Roman Space Telescope as well. About a year ago, we did a replan to accommodate the impacts of COVID, and we reset the launch date and the cost cap. Then last fall, we conducted the mission critical design review, and the Nancy Grace Roman Space Telescope passed it and is now into the fabrication and integration part of the development. I'm pleased to report to you that with the exception of the adjustment for the COVID impacts, the Roman Space Telescope remains within its cost and schedule commitments that were set all the way back in Phase A. And so the Roman team is doing a great job of managing the program within their cost commitments and obligations. And then for our smaller and medium-sized missions, the Explorers program continues to make progress. We launched the Imaging X-ray Polarimetry Explorer last December, and the first IXP science results will be reported out at the AAS meeting in a special session. We are building the next MidX, which is SphereX, and it just passed its mission critical design review. And then last October, we selected the next small explorer, the Compton Spectrometer and Imager, COSY, which will be launching in the middle of the decade. And then, of course, we received the decadal survey, which we'll be talking about more later. So we did, since the last time we had a town hall, we did receive our budget for this year, FY22, which is about 2/3 over now. And the funding we received was at about the same level as the funding we requested. Fully funded Webb, fully funded Roman. Again, this year, NASA requested $0 for SOFIA. The Congress did appropriate the $85 million needed to operate SOFIA during FY22. So we will be operating SOFIA through the end of FY22, consistent with that appropriation. As I mentioned, we were appropriated the amount of money we asked for. Since we asked for $0 from a SOFIA, we've had to find the $85 million for SOFIA from elsewhere within the astrophysics program. And so there are some impacts which we can talk about after our operating plan is approved by Congress. I was pleased to note that when the appropriators provided us with our appropriation, in the report that comes with it, which tells us what their instructions are, they did explicitly note all the recommendations of the decadal survey. And that's a note to us that they expect us to be responsive to the decadal survey. And we're looking forward to NASA's request for technology maturation to ensure continued astrophysics success. And that's certainly, we're aligned with the Congress on that goal as well. So just recently, last month, the federal government, the administration submitted its FY23 budget to Congress. That includes the NASA budget. Within the NASA budget is the Science Mission Directorate budget at NASA. It calls out 5 priorities: U.S. leadership in Earth science and addressing the climate crisis, leading the science of the Artemis program that returns humans to the moon, champion inclusion, diversity, equity, and accessibility, building a balanced and innovative program driven by the highest national priorities, which includes the decadal surveys, and advancing open science for all. I'm just going to mention one of those. So within this budget request across the entire Science Mission Directorate, there are a number of initiatives that champion inclusion, diversity, equity, and accessibility. Um, uh, that includes implementing our strategy within the broader agency plan. We are broadening our requirement for inclusion plans and solicitations. We are continuing a bridge program, which is just getting going to increase collaborations between minority serving institutions, PhD granting universities, and NASA centers. We are engaging with historically black colleges and universities. The dual anonymous peer review that was pioneered by the Hubble Space Telescope and adopted across much of astrophysics is now being adopted across the entire Science Mission Directorate. I'll be talking about some specific things that astrophysics is doing later on in this talk. This is what the budget request looks like for astrophysics. The black squares are our appropriations for the last 15 years or so, with that final black square being um, the 22 budget I just talked about. The blue square is the request for next year, fiscal year 23, and the red squares are our planning budget for the 5-year run out from now. Um, this budget is lower than the run out that we had last year. And I'll talk about what some of the content is in just a minute, but this was our run out of the 22 budget a year ago that we had previously planned to. We are now planning to a lower budget, which means we are making the hard choices between continuing all of the ongoing programs that we have planned versus implementing some of the exciting recommendations of the decadal survey. If we do stay on the path which is proposed in the red line, it will take us longer to implement all of the decadal survey than we had hoped to do when we were planning against that salmon curve up above. So with that changed budget, there's a number of changes from what we were planning a year ago. Some of them are increases, such as we have increased the amount of funding for the James Webb Space Telescope General Observer Program. We did make those budget adjustments for the Roman Space Telescope, as I mentioned. The Pioneers program of small sats has been incredibly successful so far. We selected 4 in our first round, and based on experience in other divisions, we thought that only one of them would still be in its cost box at the end of its concept study. But in fact, all 4 remained within their $20 million cost box. And so we have approved all 4 into development for flight. That means we've had to increase the Pioneers budget. And having learned that astrophysics small sats can be done within $20 million, we've increased that cadence in the out years from 1 per year to 2 per year. So the Pioneers budget has gone up in this budget request. We were able to, even though the budget was submitted in September and we didn't get the decadal survey until November, we were able to add some small amounts of funding for Great Observatory Precursor Science and time domain infrastructure systems in response to some of the recommendations in the decadal survey. Other recommendations will have to be funded in the 24 budget now, and I'll be talking about that. I've mentioned the bridge partnerships. The decadal survey did recommend that we close out the SOFIA mission after this current year. So this budget doesn't propose $0 for SOFIA. In fact, it proposes funding to fund a closeout for SOFIA. So this is a change in the agency's proposal for the future of SOFIA. Because of the reduction in our planning budget, we've had to stretch out COSI, and so they will be ramping up more slowly than they had proposed, which means they'll be launching a little bit later. And the MIDEX that we'll be selecting this fall, we will be selecting a MIDEX, but it will also be ramping up more slowly than planned, and will provide instructions to the selected team at the time of selection. And then we did announce that we'd have an AO in January of 2023 for an astrophysics probe. We will be delaying that AO for 6 to 12 months, and we will be announcing very soon what the new schedule is for the probe AO. There are things which were not changed. All the missions under development, we were able to continue their development. We were able to preserve the funding needed in the senior review for all of our operating missions, and the RNA program had no reductions whatsoever. It's still growing at the rate that we had planned. All right, I'm now going to talk about our response to the decadal survey, our initial response. What are we doing now, only 6 months after receipt of the decadal survey? So decadal surveys are very important to NASA. Every decadal survey has made a number of very impactful recommendations, including a great observatory. And all those great observatories pictured here have been impactful on astrophysics and change the way we think about the universe and what we are interested in studying. And this decadal survey has made recommendations that I'm sure will have just as big an impact. Of course, we received the decadal survey in November of 2021. The FY22 budget was submitted to Congress back in last April, not informed by this decadal survey. The 23 budget, which is being debated by Congress now, as I mentioned, was submitted by us to the White House back in September, and then was just submitted by the administration to Congress at the end of March. And it was not informed by the decadal survey. We made a few tweaks at the back end, but it is not a decadal budget that is fully informed. The first budget that will be fully informed by the decadal survey is the 2024 budget, which we are formulating now, and we will be submitting it to the White House in September. And I'll be submitting it to the agency actually by June. And then the agency will submit to the White House by September, and the White House will submit to Congress next February. So that'll be the budget that's informed by this decadal survey. I'm going to talk about the different decadal survey recommendations in groups. And the first group of recommendations are the ones that have to do with future great observatories. So the decadal survey made two recommendations. One is that we should establish a great observatories maturation program. And the second is that we should um, mature first and then implement first a mission to search for biosignatures from a robust number of habitable zone exoplanets and be capable of transformative uh, research in astrophysics. So let me tell you what NASA's been doing. So first of all, um, uh, NASA has been doing very well over the last 10 years at managing our missions within our cost commitments. This is a list of all the missions that have launched since NASA switched to committing to budget at least the 70% joint confidence level for cost and schedule. And since we did that, excluding Webb, which is, I'll tell you in a minute why you might want to exclude Webb. Excluding Webb, we have underrun our cost commitments um, by 2.3%, the whole portfolio. And so this portfolio is about $12 billion. If you add in Webb, it's almost as big as the whole portfolio. And as we all know, Webb did overrun. So when you include Webb, and we're at 3.7% overrun, you can decide which is most impactful to you. We continue to improve our ability to manage, and I just want to remind you that I've already reported that the Roman Space Telescope remains within its cost commitments. We have applied many lessons learned from managing James Webb Space Telescope and other large missions, large science missions at NASA, and we are working hard to keep Roman and all future missions within their cost boxes. We've done a good job for many missions in the past as well. So while the decadal survey was going on, NASA took the opportunity of finishing Webb to study lessons learned from our development of large missions. How can we do a better job of reducing the risk of cost overruns? And so we did what we called the Large Mission Study, and the report is available online at that URL. And then we had a separate team do an implementation plan for how we would implement the recommendations of this large mission study. The large mission study made 10 recommendations, 7 of which are being fully accepted and 3 of which are being accepted with some changes. Those are the partial accepts. Then we received the decadal survey, which had its own recommendation for the Great Observatory Maturation Program. And there was a huge amount of alignment between the recommendations that the decadal survey made and the new processes that we have already put in place at NASA in response to our internal study. So I think this is great evidence that we're on the right path to improving our performance on developing and managing large missions within our cost commitments. Now, great observatories are a critical part of our astrophysics portfolio, and I'm really excited. We're all really excited at the recommendations for a program of 3 future great observatories coming out of this decadal survey. Today, our priority is the mission success for the 2 great observatories we have in process right now, Webb and Roman. You just got an update on Webb, and I've just given you an update on Roman as well. But we are concentrating on ensuring continued success for Webb and Roman. So right this moment is not the time to start a future great observatory. However, it's a great time to prepare for that decision to start the next great observatory. And so we are going to take a deliberate multi-stage planning process to get to that decision point. Stage 1, which has already begun, will focus on enabling science and technology. Stage 2 and Stage 3 are the Great Observatory Maturation Program that was recommended by the Decadal Survey. And in Stage 2, we'll be looking at analysis of alternatives and doing those science, technology, and architecture trades that were recommended by both the NASA's Large Mission Study and the Great Observatory, I'm sorry, the Decadal Survey, where we mature the science requirements, the technology capabilities, the architectural options in conjunction with each other, because as we've learned from Webb, there's a lot of feedback, and we want to find the best spot to be where we can deliver the science with an implementable architecture, with technology which is achievable and at an acceptable cost. So that's what will happen in Stage 2. Stage 3 will look more like a traditional pre-formulation phase for a future NASA mission. The Decadal Survey estimated Stage 2 and 3, which should take about 6 years. I hope we can do them more quickly, but they're not planned out yet, so no commitments here. What are we doing in Stage 1, which has already started? Well, there's 3 tracks of activities going on in Stage 1. One are all the science activities, the ones that will lead to science knowledge and science metrics that can inform science requirements for those next great observatories. We've already conducted 1 precursor science workshop 2 weeks ago. I hope many of you were able to attend. There's going to be a second workshop later this year, which will lead to a funded call in Roses for precursor science. And precursor science is not science which complements these future great observatories. It's science which is needed or which can be used to reduce the cost and risk of those future great observatories. We'll also be setting up science metrics through our science evaluation track that will help us when we're looking at architecture and technology trades, will help us assess which ones do reduce risk and cost risk without losing the science. And then, of course, we'll be doing technology development towards all 3 of those future great observatories. We are in the process of updating our technology gap list and our technology priorities. Very soon, we'll be publishing the updated astrophysics technology report, which will have all this in it. We'll be developing the technology through our traditional methodology. So that will include the APRA and SAT elements in ROSES. It will include the directed technology that we're doing at our NASA centers, and we'll be continuing funding technology development in industry through future RFIs and RFPs. And so if you look at what we have planned for just this year, there's a lot. I think I've mentioned most of this. You can look at these charts when you download them. Has all this information in them. And of course, we'll be talking in more detail at the Program Analysis Group meetings, the PAG meetings, which will be held the Saturday and Sunday preceding the AAS meeting in Pasadena. All right, the next group of recommendations from the decadal survey that I want to talk about are the ones addressing the state of the profession, including diversity, inclusion, and workforce activities. And the decadal survey and the panel on the state of the profession said that fundamentally the pursuit of science and scientific excellence is inseparable from the humans who animate it. And that sets the context for all of the work we'll be doing at NASA with you, the community, to implement this decadal survey. We are committed to integrating inclusion, diversity, equity, and accessibility into all of our activities. We've begun that work. The decadal survey made some very specific recommendations for how we can improve the work that we're doing. And so everything that we're doing incorporates these IDEA initiatives. Let me mention a few of them, which are responsive to the decadal survey. First of all, the agency, NASA, has released an equity action plan, which you can download. And it's a comprehensive effort to look at barriers and challenges for communities that have been historically underrepresented. It is not just, part of it is about how can we improve the diversity and inclusivity of the NASA workforce, but it's also about our community, our contractors, our grantees, our partners throughout the nation and the world. And so we are assessing all of our processes, including our procurement processes and our grant policies, to identify any systemic barriers that we can remove. And increase participation by a diverse community. And NASA, of course, is a leader in aerospace and in many other areas. And we have a responsibility to model that inclusivity within the NASA workforce and within our contractor workforce as well. Um, some of specific initiatives include the bridge programs I've already mentioned, requirements in ROSES and AOs, which I'll talk about on the next chart. We've enhanced our student programs to improve access to underserved populations, and this includes the in astrophysics, it includes our high altitude student program in our balloon program, but also the Rock-On program in sounding rockets and the student airborne research program over in our science. We also have commissioned a study from the National Academies on how to increase diversity and inclusion in the leadership of our competed missions. And that study will be published very soon. We've also, as you know, increase the use of dual anonymous peer review throughout all of our astrophysics competitions. And this chart here is a demonstration of some of the impact of going to dual anonymous or double blind peer review. This is data from the Hubble General Observers Program. And on the left is the fraction of selected proposers who are first-time Hubble users. And on the right, starting with cycle 26, where we started using dual anonymous, are the fraction, again, of first-time Hubble users amongst the selected ones. And you can see a statistically significant change. It's clear that there was a implicit bias by the review panels against people that had less experience or perhaps were less well known. Whatever the implicit bias was, by making this anonymous has been removed, and we see a significant change. To me, this says that dual anonymous is absolutely worth the effort of continuing because it does make our peer reviews more responsive to the merit of the science and less responsive to the identity of the proposer. All right, the next group of recommendations from the decadal survey have to do with the science foundations of what we're doing. And they made recommendations about reporting proposal success rates, about reporting proposal demographics, and about using um, uh, uh, inclusion, diversity, equity, and accessibility as an evaluation criterion. So we always have been making available our selection statistics. Here are the selection statistics for the past 12 months. You can see that we did review over 4,500 proposals throughout our program. The average selection rate is about 25%, slightly different between the RNA programs and the mission, general observer, and guest investigator programs. And then we have a goal of letting you, the proposer, know your selection status within 150 days of receipt of proposal, and we are meeting that goal. And that's not me who makes that happen. That is the fabulous staff we have here at NASA headquarters who manage uh, the uh, the peer reviews for all of our ROSES elements, and the fabulous staff at all of our guest observer facilities for all of our operating missions that manage the observing proposals that you submit to them. We have been collecting self-reported demographic data from principal investigators since 2014. And that data is available for our analysis. And so here is an example of analysis where we sliced by self-identified race. And on the left is the distribution of self-identified race for submitted proposals, for 25,000 proposals submitted across all of the Science Mission Directorate over that 6-year period. And of the 6,000 selected proposals, the chart on the right shows the distribution of self-identified race. And so we do have the data, we are collecting the data as recommended by the Decadal Survey, and we can query that data as appropriate. And then the final recommendation in this group from the Decadal Survey was that we should consider including diversity in the evaluation of funding awards. Here's what we're doing. Last year, before we got the Decadal Survey, we ran a pilot program in the astrophysics theory program, and PRISM, which is the another ROSES program in the lunar exploration program, where we asked PIs to give us an inclusion plan, which describes how they will run their investigation in a way to make sure that their team is inclusive, and that they are paying attention to the career needs of early career members of their teams. We evaluated those inclusion plans, and we gave feedback to the PIs, and we analyzed how this pilot went. And you can find the white paper in the place where I always send you to download things, that one page. This year, there are 7 astrophysics ROSES elements and 6 elements elsewhere in Science Mission Directorate that are requiring inclusion plans. And we'll again evaluate them. And we'll again give feedback to the PIs, and we will not use these evaluations of the inclusion plans to impact the selection. However, we will require selected PIs to remedy any unacceptable inclusion plans before we initiate funding. Next year, we would like to extend this plan to be responsive to the decadal survey, and not select inclusion plans which are unacceptable. And so we have no plans to try to average the rating of your inclusion plan with your science merit, or rather we'll use the review of your inclusion plan as feedback as we go forward with deciding whether or not to select any scientifically meritorious proposal. The next group of recommendations from the Decadal Survey has to do with the foundations of our science and technology. Many of these are in work, and I'll just make some comments on the next pages. Many of them are recommendations to increase funding, so that's tied up in our budget formulation process. But let me just mention a few of them. I think actually Uh, let me mention them right now because this is the page I have it on. So there was a recommendation for theory. Um, uh, uh, on the one hand, that we would go to annual calls. And on the other hand, they thought the selection rate at 22% with biannual calls was too low. When we go to annual calls, the selection rate goes down by a factor of 2. So these two findings by the Decadal Survey are in tension, and we're still working uh, towards a recommendation in that area. We're coordinating. I think that's all that I have here. Um, that's worth taking the time. I wanted to report out to you on what does the funding to the community look like. And so ignore the blue line for the moment. The sand chart uses the left scale, and this is the funding over the last this is over 20 years of funding to the community from astrophysics, where it's the RNA program, the postdocs program, which is currently the Hubble postdoc program in orange, the technology program through SAT, which started up around 2010, and then all of the various mission GEO programs. And you can see the great growth in GEO programs starting uh, this year and next year as we turn on the James Webb Space Telescope GEO program. And so the blue line is what fraction of the total astrophysics budget does this community funding represent? And you can see that historically it's been around 13%, between 10 and 15. Up until this year, the wiggles like that increase around FY11 and that decrease around FY20, those are not caused by changes in the community funding. As you can see, those are caused by back in FY11, the total astrophysics budget went down, but we did not take the money out of the community. And in FY20 and 21, the total budget went up because we were simultaneously building Roman and Webb. And that was a temporary increase in the top of the astrophysics budget. All right. There was a recommendation to end the SOFIA mission at the end of its current extended mission, which is the end of September this year. NASA and its partners at the German Space Agency have announced that we will conclude the SOFIA mission at the end of this current mission extension after a successful 8 years of science. And then I think this is the final category, sustaining programs and medium scale opportunities. We're maintaining our Explorers cadence. I've mentioned that we will announce an update shortly on the time of the Astrophysics Probe AO, but we are having an Astrophysics Probe AO in 2023. The Committee on Astronomy and Astrophysics is conducting a non-advocate review of the Roman science program as recommended by the Decadal Survey, and they recommended a time domain program. So we are committed to realizing the science of the time domain astronomy and multi-messenger astrophysics, or TDAM program. We have a workshop planned with the community for August of this year. Now we have a portfolio of missions and planned missions, which is includes a lot of capabilities which are being used and will be used to address the priorities of time domain astronomy and multi-messenger astrophysics. Um, uh, and one of the recommendations of the Decadal Survey is to establish some sort of advisory group to set the priorities for future missions in time domain astronomy and multi-messenger astrophysics follow-up missions. And so we have a lot of capabilities now. What is the highest priority capability that we should add to this portfolio? Is it something that's not present? Is it, having a follow-on mission for some of the older missions, which won't last forever? That our plans are to set up that group to help us set those community-based priorities in the time period following our August workshop. Uh, um, in addition, let's see. So what have we got going in TDAM that I haven't mentioned? I've mentioned that we, in addition to flight missions, this is the second bullet. We know that we need to set up coordination, standards, uh, data archives, next generation transient alerts, ways to fund the community, an entire infrastructure that is focused on enabling time domain astronomy and multi-messenger astrophysics. And this is an area that we were able to get some funding into our FY23 budget request. And if the appropriation maintains that funding, we'll be able to get those activities started in fiscal year 23. And I've already mentioned our workshop. And the last thing I'll say is that I've talked to about a dozen international space agencies and mentioned that we would very much like to make this time domain astrophysics portfolio a worldwide portfolio where between all of the space faring agencies, we are able to realize the capabilities needed to address our highest priority time domain astrophysics. And everybody was very excited about that. We will be setting up coordination with our international partners. And we're already talking to several international agencies about missions they're doing, which are responsive to the Decadal Survey recommendations. So how can NASA partner on those missions and realize those capabilities and benefits for the U.S. community without NASA building missions all by itself. So those are the things that we have put in place already for responding to the Decadal Survey. I will just go back where I started and say we have a very exciting and capable existing portfolio, which are the blue and the green missions. We've got a lot of missions in development, which are the orange and the yellow missions. And then the Decadal Survey will lead to additional missions to add to the exciting program that we have in NASA astrophysics. So thank you very much for listening, and we do have time for questions. So I'm going to invite Valerie Connaughton to please join us, join
Okay.
me.
I'm
Yep. Hi,
here. Thank
Valerie.
you, Paul. Hi, Paul. Thank you. So we have a lot of questions on the portal. First up, we have several questions on SOFIA and on NASA's decision to conclude the mission. Can you address them all?
Sure. So SOFIA, let's see. Oh, sorry. So NASA, as I mentioned, NASA and the German Space Agency will conclude the SOFIA mission after 8 successful years of science. We're going to end operations no later than September 30th at the conclusion of the currently approved mission extension. The Decadal Survey concluded that SOFIA's science productivity does not justify its operating costs. And the report also found that SOFIA's capabilities do not significantly overlap with the science priorities that the Decadal Survey identified for the next decade and beyond. I agree with people who state that SOFIA has unique observational capabilities that are not duplicated elsewhere. And I agree that SOFIA has conducted some unique science over its 11-year operational lifetime and its 8-year period of full science operations. But it's also very expensive to operate SOFIA. It annually costs almost as much as the Hubble Space Telescope, and that funding comes out of a limited NASA astrophysics budget. And this year is an example where it is displacing other astrophysics in our budget. So, and we cannot and we do not provide every observational capability at every wavelength. So within our finite budget, we prioritize, and that's what the Decadal Survey has helped us do. So the NASA decision to end the SOFIA mission isn't based on the conclusion that SOFIA cannot do science. It is based on the Decadal Survey's conclusion that the science SOFIA can do doesn't justify its high costs. And there was a question about will we do all the science that was selected in cycle 10? And the end of SOFIA science operations in September this year means that the complete Cycle 10 science campaign cannot be completed. I know that the SOFIA Science Project is working hard to ensure that the remaining months and flights of operations are used to create an enduring science legacy of this unique observatory. There was a question that said, what's different this year? NASA has zeroed out SOFIA in the past, and Congress keeps restoring it. What's different this year is that the Decadal Survey has recommended ending the SOFIA science mission after the current mission extension. The Congress, in their appropriation this year, did explicitly recognize all of the recommendations in the Decadal Survey. What else is different this year is that NASA didn't propose a zero for SOFIA. We proposed a closeout budget for SOFIA. But as always, the NASA budget request is just that, a request, and Congress will make the ultimate decision on what NASA projects receive funding.
Thank you, Paul. Next up, we have several questions on NASA's handling of the concerns over the name of the James Webb Space Telescope. Can you address those, please?
Yes, I will do so. First of all, NASA leadership took very seriously the investigation into whether or not the telescope should be renamed. For decades, it's clear that discrimination against LGBTQ plus federal employees wasn't merely tolerated, it was actually shamefully promoted by federal policies. And the Lavender Scare that took place following World War II is a painful part of America's story and the struggle for LGBTQ plus equality. Now, based on the historical research available at this time, NASA decided not to rename the James Webb Space Telescope. However, the NASA historian and an independent contract historian are wrapping up their research from the historical archives that were closed to COVID and have been reopened. And NASA plans to share information about their research after it is complete. There were questions about some of the advice we've gotten, and we're certainly, I mean, whether we were even aware of the letter from the AAS. So we're certainly aware that the Astrophysics Advisory Committee recommended that we publish a report on the historical research that led to the NASA decisions. And we are certainly aware of the letter from the AAS that requested a number of things, including a study by an independent historian and a revision of NASA's policies for naming missions. I don't have any further updates in response to those requests to NASA than what I've already said. Speaking for myself, I recognize that NASA's decision not to rename the James Webb Space Telescope is painful to some, and it seems wrong to many. I've stated that NASA will provide more information after the historians complete their research. And if new information is uncovered, then NASA has stated that it will be taken into account. And I'm sure that at our town hall in Pasadena, we'll revisit this area, and I'll have whatever updates I have in the next month.
Next up, we have a question about a pronoun test project at Goddard Space Flight Center. I'm not going to read the question since it incorrectly states the nature of this IT test, but can you address the intent of the question?
Yes. So through an effort to create a more inclusive workplace, NASA recently completed an information technology IT project at Goddard Space Flight Center that allowed approximately 125 employees spread throughout the agency to test the option of including their gender pronouns in NASA's email display fields. And that's the wrong thing. In NASA's contact list that we keep of all employees, in addition to their name, center, and organizational code, which is the only things which are in there right now. And it was a test, and the learnings from this test will be used to inform the advancement of diversity, equity, inclusion, accessibility policies. Um, NASA is fully committed to supporting every employee's right to be addressed by their chosen name and pronouns. All NASA employees have the option and the flexibility to include their gender pronouns in their customized email signature blocks. That has not changed. And this and that option is supported by NASA leadership, so that all employees can have the option to share their gender identities and to show allyship to the LGBTQ plus community.
Thank you, Paul. Now turning to RNA, what are NASA's plans with respect to the astrophysics theory program budget and cadence?
Yeah, I addressed this quickly during the slides, but I'll give a longer answer now. So the decadal survey found that the selection rate in the theory program at 22% is too low. They also recommended that we return to an annual cadence for the theory program. These two statements are in tension with each other. We originally went to the biannual cadence in the theory program because it approximately doubled the selection rate within the same budget. So we're currently studying options for responding to both of these decadal survey recommendations. We discussed our preliminary thoughts with the Astrophysics Advisory Committee at their March meeting, and we will discuss our revised thoughts and possible paths forward with the Astrophysics Advisory Committee at their July meeting. That is an open meeting. Anybody who is interested in this topic, like whoever submitted the question and all the people, and anybody who upvoted it, you're welcome to attend that meeting. It has a public comment period as well. There will not be a theory call this year, no matter what we do in the future, because last year we gave away all the money. We selected all the new investigations for 2 years worth of new starts. So we didn't save any money for any new selections this year. So even if we go to an annual call, the next call will be next year. And if we go to an annual call, it'll also happen the year after that. I did talk about our out-year planning budget, which is significantly constrained. So it's clear that we can't implement all the recommendations of the decadal survey immediately, and we are parsing through the decadal survey to identify the priorities on which recommendations should be implemented sooner, given a constrained budget situation.
Okay, in the questions that were submitted in advance, there were several questions about NASA's plan for GOMAP and future great observatories, but Paul addressed these during the town hall, so I'm not going to ask them. There were a few other questions submitted during the portal during Paul's talk, and I answered some of them in the chat. I provided links to the SMD Bridge program for minority serving institutions.
Do you want me to read through them quickly and just answer the ones I can in one sentence?
I can do that for you if you want.
Okay, go ahead.
So the first one is, to avoid future cost overruns, why not migrate more astrophysics mission components to industry partners?
Most astrophysics missions are built by industry already.
Okay. The next one, this was actually on your slide, but you didn't talk about it. Given the difficulty for existing projects to get flight opportunities, what are NASA's plans to restore the scientific balloon program to a healthier launch cadence?
So the launch cadence recently has been due a lot to COVID, and we're always subject to weather. And Antarctica is impacted by the 10-year National Science Foundation redevelopment of the Antarctic science capabilities. So what are we doing? We already launch as many as we can with each campaign. Um, uh, we are looking for a second domestic launch site to replace Palestine. because Palestine, the population around Palestine, Texas, has become too large to safely launch from there. So we're looking for a second domestic site where we can launch in the evening for nighttime flights. And we'll continue Fort Sumner, where we always have to launch in the morning. We'll continue in New Zealand, where we do our superpressure balloon launches. We'll continue out of Sweden, where we launch our transatlantic flights, and we'll continue out of Antarctica, where we're doing our long duration balloons. Uh, I, the queue we have right now is mostly due to COVID. In normal times, we don't have a queue accumulating because there aren't enough launch opportunities.
The next one is about the Pioneers program, and someone is wondering whether the cap will remain at $20 million per mission with the increased cadence.
Yes, the cap will remain at $20 million. And so for the increased cadence, we doubled our budget. So we are from 20 million a year to 40 million a year.
Then there's a question about the probe due date. I think you stated this in your talk, but maybe reiterate. Is it possible to give a no earlier than due date for the first probe proposal?
We'll be making an announcement very soon, and so we're not going to make an announcement at this town hall, but you'll see it through NSPIRES and all the other ways that we send out announcements.
Okay, I think that concludes the new questions. There is one question about the Hubble postdoc program, and asking why doesn't Chandra and Sophia and Spitzer have their own programs?
Yeah, so
Yeah.
yeah, so many years ago, everybody had their own postdoc program. We then merged them into 3 programs. The Hubble program run by the Space Telescope Institute, the Einstein program run by the Chandra X-ray Center, and the Sagan program run by the NASA Exoplanet Science Institute. And then we actually merged the 3 into 1. And so the NASA Hubble Fellowship Program covers all areas of NASA science. It's not linked to the Hubble Space Telescope. And it has, in fact, we still identify 3 strands of fellows, the Einstein Fellows, the Sagan Fellows, and the Hubble Fellows within the program. And we just recently did a independent review of the Hubble Fellowship Program, I think the first one in 30 years. You can find the report of that review at the usual place, science.nasa.gov/documents/ science.nasa.gov/astrophysics/documents. And the recommendations from that report. We're going to be having a splinter session at the AAS meeting in Pasadena to talk about the recommendations and how we can make that better. And so if the person who asked that question thinks that the Hubble Fellowship Program isn't properly covering the science of all those other missions, we'd love to hear from them.
I think some of the other questions are not things we could really answer at this time, but there is one interesting philosophical question about technology funding. SAT and GOMAP program elements seem to have the same objective. Will SAT be replaced by GOMAP or be reaimed in some fashion?
They're complementary, not redundant. SAT is our competed strategic astrophysics technology program. So for those technologies which are best developed by PI-led investigation teams, they'll be proposed through and funded through SAT. GOMAP is our overall maturation program, which will be coordinating not only the technology development, and the technology development will be SAT plus directed technology at centers plus industry funded technology development, but it will also include the analysis of alternatives, the architectural trades that will start up at some point, and eventually science definition teams and all the other activities that need to take place within the community and within the agency and within industry that will eventually lead to formulating that next great observatory. So GOMAP is the big umbrella over it, and SAT is one of the elements.
Okay, that actually concludes, I think, all the questions that we can provide a useful answer to at the moment. So thank you, Paul, for addressing those questions.
Thank you, Valerie, and thank you everybody for joining us. I really do look forward to seeing you in person in Pasadena. If you're attending the meeting, please come up and say hello to me and say hello to all your program officers from NASA headquarters who would love to see you too after several years of missing you. Thank you very much, everybody. See you in Pasadena.